Hi, I'm Ronnie Rogan, and today I will be talking to you about my software application, Wordle Solver. So today we're going to be describing what exactly Wordle Solver is and two of the architectures that I considered client-server and rule-based, the comparison between the two, and then finally a demo. So first of all, what is Wordle Solver? So there's a popular game called Wordle, which is a word game where within 6 guesses, you need to guess the mystery 5-letter word. So as you input your guesses, letters will turn gray if they're not in the word, yellow if they're in the word, but you put it in the incorrect spot, or green if you have it in the right spot. So Wordle Solver uses your user input guesses into Wordle to determine what the mystery word might be. So just to describe how it works a little bit better, a little bit visually. So say that this is my 5-letter word input, and I received this as my feedback. So I have 3 gray letters, a yellow letter, and a green letter. So these gray blocks would represent my possible words that I have. So with your gray letters, any word that contains those letters, I can immediately rule out. So say these contain one of the gray letters, I can take them out of my possible word list. Next, I look at the yellow letters. So they have to be the word. If a word does not contain that letter, we know that's invalid and we can take that out. Next, we know that if it's in the exact same spot, that is another invalid word because we have already narrowed down the fact that it can't be there. So that word can now immediately be taken out. Next, it must contain a green letter in the exact same spot. So say that this is the only word that contains that letter in that spot, then we know it must be this word. So there's some very simple solutions to solving a Wordle. So that led to the possibility of these next 2 architectures that I'm going to be talking about, the first one being client-server. So here you can see there's the client and the server. Within the client, there is the GUI, and from the GUI, the client has the option to input guesses or display the word list. There are 2 associated remote procedural calls with that. The first one is the submit guess, which takes in those letter and color data and submits that to the server. The second one simply retrieves the word list from the server. So on the server side, you have your Wordle logic, which receives the submitted guesses with the colors to update the Wordle state. And that Wordle state simply just contains the possible valid words, which then can be retrieved by the get words procedure call. So for the class diagram, it's pretty simple. So you have the GUI, which contains your letter inputs and color inputs, as well as just some display information such as like the unused letters, gray, yellow, green letters. And there are 3 functions that you can call from the GUI: submit with your associated colors, the get word list, and display words. So this interacts with Wordle logic. On Wordle logic, it maintains a word list, which is a word file object, and your used letters. So on the Wordle logic side, from that submit, it can then add green, yellow, gray letters, as well as update the used letters. And then you can get the word list, which will return your string or array of strings with possible words. So the word file is an object that contains a string of the possible words that can be used in the Wordle. The get words does not retrieve the entire thing because that would be extremely long, especially for the first few guesses. So it only retrieves the top 10 from the word file object. And from the word file, it can read and write. So a little bit of a mapping here. So the GUI is represented by the GUI class, and your input guess and display word list are the submit and display words functions from within the GUI class. submit guess and get words are also the submit and the get word list from the Wordle logic side. Wordle logic is obviously the Wordle logic component, and the Wordle state is maintained from within the word file object. So that maintains like what letters have been used and a different object for your valid word list. So the second architecture here is the rule-based architecture. So within this one, you have the user interface, which has these two options, the letter and color input, which is inputted by the user, and the words. Letter and color input has a procedure call of submit guess, and the get words has a procedure call of get words. And those are inferenced by the inference engine. The submit guess is chosen to be the green, yellow, or gray letter rule, which then goes down into the data access into the knowledge base and up into those rules, whereas the get rules is treated as a fact and then simply retrieves the current valid word list. So here's the class diagram. It's pretty similar to the first one. So you have the GUI on this side with your letter and color inputs, as well as some of the display values there of use gray, yellow, and green letters. And you also have the functions of submit, word list, and display word list. That goes into the inference engine, the submit letters one. And based off of the letter and color, it is then going to call the appropriate rule based off of the color. And get word list is simply just a fact, which will retrieve your word list from the knowledge base. So on the knowledge base side, you have valid words and used letters represented as a file object, and that file object simply just contains some data in the form of a string. It allows you to read and write. And the add green, yellow, gray, and used letter simply just updates the rules, and the get word list retrieves the fact. So here is the mapping for that. The user interface is the GUI. Submit guess is the submit function within the GUI. Same with get words and get word list. The inference engine is represented by the inference engine class. Data access is those file objects. The knowledge base is represented by the knowledge base component. Your rules are the adding green, yellow, gray, and used letters, and your facts are the get word list. So let's compare those two a little bit. So the client server, some of the pros here is that it's a centralized computation and data and user data entry. So the only user input into this program is essentially just the entry. So what is the letter and what is the color? There's no real complex action going on here. And it's also a lot, since the logic is the same for every Wordle game, it's a lot easier to have one central computation. Some of the cons here, though, is that there is no real need for scalability for Wordle Solver. There's only so many 5-letter words. There's no need for a large database, and there are not going to be millions of people using Wordle Solver, so that seems a bit of a waste of resources. And there's really no need to have a separate server because, again, there's no need to have a high processing power server to look through maybe a couple thousand words, which can be easily run on the client side only. So rules-based, some of the pros are the data queries are pretty simple. It's simply what color is this letter to narrow down the word list. There's also a pretty low number of rules. There's only so many colors. There's like 3. And then there's no high performance needed. However, some of the cons is that rules may interact with one another. For example, if there are multiple letters, same of same letters within one word. One might be yellow, another might be green, or one might be yellow and one might be gray. So you have to be able to handle that possibility, as well as the ability to change a yellow letter into a green letter. So you have to be able to update those rules. So I ended up going with the rule-based approach. So client server just didn't make as much sense as rule-based did, due to the fact that it really seemed like overkill. You only need to run this on the client side. There's no need for a server. And the cons of the rule-based being the rule interaction and amount of rules didn't seem to really apply, because although there are some rule interactions, they're not that complex and can be easily handled, and you can easily handle the edge cases. And it just seems that rule-based handles the problem in a much simpler way. So compilation and demo. So here's the screenshot of the code compilation, and now for the live demo. So I've started the Wordle Solver here. So here is the home page. So this just explains the rules of Wordle again. So I can go ahead and solve a Wordle. So I already have Wordle pulled up here. So let's start with my initial guess. Let's do a do. And we can see that A and E are in the word. They're not in the correct space. So I'm going to go ahead and put those in here. That's yellow, and then these are gray. That one's yellow, and that one's gray. So I'm going to hit submit here, and here you can see just a display of the known data. So here are the unused letters, and there are quite a few there. These are not in the word. These are in the word, but I don't know the correct spot for them now. And I don't have any green letters yet. And you can just see here's my previous guess displayed here with the correct colors. And here's some example words that fit this criteria. And it's limited to 10, simply because if I displayed all of them, there are like thousands of words that fit this criteria. So let's do space as my next guess. I got a couple of green letters there, so S-P-A-C-E. So S is green, A is correct, and E is correct. So I hit submit there. And now it looks like I only have 2 options. So at this point, I can just pick one. Let's do scare. And it looks like that is correct. So I can go ahead and reset this, and if I wanted to, I could play a different Wordle game. If you just keep hitting reset, it will reset the program for you. Yes, so that is the end of my presentation. Thank you.